Fantastic. Thanks for joining us today. I don't know if anyone remembers this ad. This was how the Mac and the PC used to introduce themselves. So I'm going to introduce myself. I'm Simon. I'm a data engineer.
I'm Ned. I'm a data scientist.
And there's something from this ad that I really wanted to point out. Once upon a time, we used to use different tools to try and solve the same kind of problem. Now, as a data engineer and a data scientist, we've traditionally been using different tools sometimes to solve some of the same problems. And over time, Ned and I actually both gravitated towards DuckDB, and so much so that we decided we were very passionate about this project. We decided to write a book together. Awesome. So today we actually wanted to introduce DuckDB and hopefully convince some of you that it's something that you should put into your data analyst and data workflow. So you're probably sitting there asking the very basic question, what on earth is DuckDB? Now I can give you this Wikipedia-style definition. DuckDB is a fast in-process analytical database. That is both accurate and probably not very helpful. So I want to break this down just so you can sort of orientate yourself into what on earth is DuckDB. So DuckDB, as an in-process OLAP SQL database, I just want to break down some of these semantics. RDBMS, or Database Management System, we know these things. These are things that have characteristics such as ACID compliance. They understand SQL. You can write analytical queries. We all understand when we talk about databases what we're talking about here. SQL query language. Now, I'm not talking about a pared-down version of SQL. I'm talking about the same SQL engine that powers something like Postgres. When we're talking about using the power of SQL, we actually want to have that whole basket of SQL tools at our disposal. Online analytical processing. We actually are today talking about something that's in that OLAP space. We're talking about taking huge and columnar-style databases and being able to process data at scale. And maybe the distinction we really want to draw out here is we're going to be talking about in-process processing. So this is very much a compiled application that sits within either your Python application, your data stream application, or your front-end development. So that's a bit of a word salad. So let's kind of break this down into a bit of a quadrant. Everyone loves a quadrant diagram. Now, let's just do a bit of a distinction here. You probably all had the interview question, what is the difference between an OLTP database and an OLAP database? Now, if you start thinking about, well, what are the characteristics of some of these databases, we kind of can start thinking about the products that are out there already. SQLite is by far and away the most prevalent database above and beyond anything else. There's over 1 billion SQLite databases out there. The characteristics are it's compiled into an application, and it's very much the transactional OLTP style database. If you've got a phone in your pocket, you have a SQLite database in your pocket. Now, if we start thinking about those sort of client-server styles of RDBMSs, these are the classic ones. You've got your Oracles, you've got your Postgres, you've got your MySQL, but they very much have that sort of characteristics of their transactional databases, but they've kind of got a port, a process, and a client-server architecture. So let's think about the other side of this, this trade-off. The OLAP world, these are very much the ClickHouses of the world, the cloud warehouses, the snowflakes of the world, and these are kind of the ones when you start thinking about OLAP style and analytical processing, we're very much thinking about the client-server architecture that's going to support those style of workloads. Now you're probably noticing, hey, there's nothing in that corner up there. How do we actually solve those in-process, in-memory, real-time situations when we're talking about OLAP workloads? And that's where DuckDB falls in. And when I'm talking about DuckDB, I am talking about something that is completely open source, it's completely free, and it's something that we've both fallen in love with. Now, I'm hoping I'm surrounded by friends here, so I kind of want to do a little bit of a confession. I am both old and cynical. Now, I am old and cynical. That means that every time someone comes up with a new U-Boot tool, I go, we're not going to need it. We can just use the things that have been around for a really long time. So these kind of Reddit threads sort of sit well with me because I go, why on earth can we justify a new tool? So I'm going to try and spend a few minutes here trying to justify why DuckDB gets me excited and why we should all be thinking about adding that to our toolkit. Now, DuckDB is extraordinarily versatile. So it is a great answer to solving a whole myriad of answers. Now, I'll be the first to confess it's not always the best answer, but it's the cross-cutting nature of DuckDB that makes it unique. So we can talk about DuckDB as being a really great answer for things like data analysis, and Ned's going to talk about more of that in a moment. We can legitimately have it in our data pipelines. It's very, very comparable to a lot of these other technologies. It sits really well in data lake querying. You can use it for data warehousing, data cubes, and probably quite uniquely, you can also build really, really reactive and quite rich data applications. So the takeaway here is that DuckDB can comparably be the answer to all of these styles of workloads. Now, I am a data engineer, so I kind of just wanted to give you a bit of a glimpse about why, as a data engineer, I get excited by DuckDB. Now, one of the things that I first discovered about DuckDB is how much is done for you automatically. Now, I'm going to give you a really basic example here. I am a consultant. I walk around to different customer sites. Sometimes I have to do something really exciting like load a bunch of CSV files into a database. Now, this is not the world's most exciting thing, but sometimes I have to just think, well, I don't know about the line termination. I don't know about the schema. Maybe I've got a huge sort of nested directory of files. One of the beautiful things from DuckDB is you can just write little things like this, read CSV with a sort of a glob syntax, and there's an awful lot that happens automatically under the covers. So I can do this. I can point it to a directory or nested directory of files, and it's going to pull out a lot of things automatically for me. It's going to be pulling out the headers. It's also going to be pulling out the data types. And it does this because it's automatically sniffing the types of files there. And if there's a schema evolution under the covers, it takes care of that for you. Now, I'm not going to impress anyone in this room by telling you a tool can read CSV files, but I hope that I can actually entice you with the concept that if you can hide away a lot of the black magic and just focus on the outcomes, something like DuckDB can actually remove a lot of those paper cuts for you automatically. Alrighty. So let's kind of lift this up. One of the things I love about DuckDB is it can handle reading Parquet files from object stores. So if you've got your S3, your Google Blob storage, your LakeFS, all you have to do is potentially wrap a little secret, then say DuckDB, go forward and read that bucket. And if it's a nested bucket and a whole bunch of Parquet files that you've never seen before, DuckDB will just read it for you automatically. This is in process, it's in your laptop, it's just a sort of a superpower. Alrighty, if you've got a REST API, you can use the read JSON function to hit up that API. It could be a private API, or if you've got a bearer token, you can put that in, and DuckDB will just read it. It gives you a bit of a superpower to write SQL directly against a REST API. And the other cool thing about DuckDB is it's got this huge collection of extensions. So I often have to attach to things like SQLite databases, Postgres databases, MySQL databases. You install an extension, point DuckDB at it, and again, you're solving a lot of those sort of paper cut things straightforward. Here's a quick way of, for example, reading your iMessage directly from DuckDB. Alrighty, so those hopefully gives you a bit of a sense of the building blocks. I want to now take a bit more of a deep dive into some of the cool things under the covers. So one thing that you would have heard about many times today is this idea of a data lakehouse. Now, one of the things I really love and appreciate about DuckDB is how much is happening under the covers when you're doing something like a read Parquet off an object store. Now, this looks like a fairly innocuous statement. You could just naively write a parser to do this kind of thing. An awful lot is happening under the covers when you're using DuckDB. For example, it's doing a projection push down into a Parquet file. So if you have big, wide Parquet files, and maybe you want the first column and the 48th column, DuckDB is smart enough to only pull out essentially the ranges of the file that's necessary to satisfy that query. It's essentially avoiding a lot of work, which is great for local files, and it's an absolute godsend if you're actually pulling stuff across the wire. Alrighty, it also understands Hive partitioning, which means that if you've got your files stored on a Hadoop system or any Hive partitioned directory layout, DuckDB understands that, which again means that it's avoiding unnecessary work if you're doing a query against the partition keys. And one of the really cool things is it understands pushdowns into zone maps. So if you're actually creating your Parquet files and it's actually generating the zone maps and essentially a form of metadata, the Parquet reader actually understands that and again is smart enough to avoid the maps within the Parquet file just to essentially speed things up. So that's all very, very geeky and very, very wordy, but the TLDR here is it's incredibly fast. If you just do the classic one of point DuckDB to the New York taxi data set, it will probably confuse you because you think it's broken. It's just incredibly fast. Alrighty, I said it's extensible. Here's just a sort of a bit of a snapshot of some of the extensions. One of my favorite extensions for DuckDB is the geospatial extensions. I'm not talking about just a lightweight version of geospatial extensions. I'm not talking about a cut down set that, things like, I don't know, BigQuery or Snowflake do under the covers in a mediocre way. I'm talking about the entire PostGIS geospatial extensions. And if that's not enough, it also understands Uber H3 style extensions as well. So it's really, really quite a comprehensive set of data analysis tools. Alrighty, I'm just going to try one last thing to kind of convince you. I'm a Sydney-sider, I'm arriving in Melbourne, and I'm thinking to myself, I understand that you folks like coffee. How do I actually get a bit of a sense around the coffee places around here? So I got onto the web, I discovered there's a public data set of all the restaurants, bars, and cafes with a lat long, and it's just a public API. I can also do a geospatial bounding box around the block that we're on, and you know what? I can write myself a really, really quick query to read that public file, read my geospatial stuff, and then tell me the cafes that I should go to after this meeting. Hopefully that gives you a bit of a sense around the building blocks and how the building blocks come together. And as a data engineer, I just appreciate all those building blocks making my life easier. I'm going to pass it to a more comparable adult here.
Can I jump onto that?
Oh, yeah.
That's Thanks, Simon. Cool. So, yeah, I'm a data scientist. Anyone else think of themselves as a data scientist here? We've got a couple? Okay, cool. Well, hopefully I can convince you folks and the data scientists that you work with. Yeah, I'm just going to dive, I guess, because, some people might think, hey, data science, why do I need a database in SQL? I don't know. That seems like a whole thing. So hopefully I'll sort of convince you why this actually makes sense. So first and foremost, you can use a DuckDB with the tools that you already use. And so for data scientists, that's most likely Python and R. It's interesting, actually, that so DuckDB was originally designed for data scientists and analysts in mind, the idea being to help give them sort of database management tools that folks have in sort of OLTP world, but not so much for analytics on your desktop. So that was sort of the original idea, and then it turns out that, hey, a lot of these features of DuckDB are really good for building data products that folks like Simon and data engineers get excited about. So there's actually some really rich R integrations as well as Python, which we'll get into. So the first thing I'm going to jump into is talking a bit about giving you a sense of the streamlined experience. It's like, it's not like part of the benefit of DuckDB is that it's an in-process database. You don't have to install a client-server sort of situation. So let's say we had a whole bunch of JSON lines, new line delimited JSON data, and we want to just read out all the records and start pulling out data and creating a data set, doing something with it. We've got that in this directory here. Step one, I'm going to pip install, so we're doing this in Python. If you want to see how it works in R, have a look at our book. Pip install DuckDB, and then we're basically off to the races here. In our Python session, we're going to import DuckDB, and what we're going to do is connect to the in-memory database with duckdb.sql. So there's two ways we can use DuckDB. Just as a transient in-memory database, it'll go away when you close the process down, or as a persistent database on disk. So this query here, what we're doing is we're just saying, hey, glob over all the JSON files and pull out these fields. Also, by the way, please give me the file name that each record came from within that original location, and then let's export it to Parquet. So it's really simple, straightforward. Instead of doing to Parquet, we could have dumped it out to CSV, or even actually directly to a pandas or polars data frame, which is pretty convenient. But you may not want to sort of do a once-off data wrangle. You may actually want to persist it on disk. So in that case, what we're going to do is a common pattern you see in Python. We create a new connection to our on-disk database. And now that connection object, we can issue SQL queries against it. And so you'll see the same query again, but we're actually creating a table. And so now that table, that users table, is sitting inside the database. When we close that connection, it'll keep persisting, and we can reopen it again and start issuing queries, such as the simple count that we have there. So I think just sort of highlighting that it's sort of really simple to just to get in, start using some of these features, similar to some of those data wrangling features that Simon also mentioned, but just like no sort of faffing around with installing any servers or authentication, anything like that. Another thing we want to talk about is, for those folks who maybe aren't so keen on SQL, who just, wish maybe it was just a little bit friendlier to use, DuckDB has a strong emphasis on friendly SQL. So given that if you're going to be doing a lot of data analysis, that involves iteration, writing queries and queries. And so hey, it'd be nicer if there was just less paper cuts. So some popular examples, there's heaps more of these. Nice select, exclude, and replace. So rather than having to sort of enumerate everything but omit one, let's just say let's omit the city. Or maybe we actually want to replace the value of city. You can even dynamically select columns with regexes. You could even put a lambda expression in there, which is really cool. From first syntax is really nice. Maybe you've thought, hey, wouldn't it make more sense to do from the table? Now let's select things and do stuff because it's the data source that you care about. You can do that in DuckDB. And if you're selecting star, you can actually just omit the select clause. So just from table and you'll get everything. We can even do, and if you're a Pythonista, you'll appreciate this, you can even do list comprehensions. So you can see here that I'm just going through and lowercasing all the elements in this array, which is a data type in DuckDB of strings, and then just conditionally pulling out if they're not an empty, and that's now the value that data element gives us. And lastly, not lastly from all the friendly SQL enhancements, but last for this one, is trailing commas. You can have a comma at the end of, and because hey, it's 2024, and maybe we can have nice things for once. So performance, I think one of the real benefits is that as a data scientist, you pull down some data from somewhere, you can crunch that to you can scale larger sets of data and also faster on your local machine, on your laptop, or maybe it's an instance in the cloud. But you can take that further before you need to go, all right, it's time I get a distributed query solution, or whatever that is, whether it's Ray, Dask, Snowflake, Spark, or what have you. And there's a bunch of things that go into why DuckDB does this. It's not like it has one particular magic trick. It's a whole bunch of research and effort and drawing together research from this is actually created by some researchers over in the Netherlands, but also on analytical database. I think there's something like about at least sort of 10 PhDs worth of content that have gone into this. So things like vectorized query execution for that blazing fast through columnar operations, multi-core processing to take advantage of your cores. Out-of-core processing is really a really important one because it means that you can crunch data sets that don't fit into your disk. If it's too large, most of the operators, except for in some complex circumstances, can spill over to disk, and if you've got a fast SSD, it might take a bit longer to complete, but hey, it is likely to finish, which is just, again, allowing you to scale up your analysis to higher degrees. I'll talk about some of the lazy evaluation stuff in a second. And I guess sort of one way to think about this is you might have this use case of a common pattern you might see is pulling data down from something like Spark or maybe Snowflake or whatever it is you're connecting to, and now I'm going to work with that sort of sample on my local machine with pandas. I kind of feel like you can do the same thing with DuckDB. It's sort of, if you still want to work in pandas or polars, do that. You don't have to stop using them, but it's use the right tool for the relevant bit of the pipeline. Get DuckDB to handle that performant sort of crunching, but in this case, it's on your laptop. So I mentioned before that we had the lazy evaluation side of things. So if we're in Python in particular here, this lazy evaluation is really nice. So when we run one of these .SQL queries, what we get back is actually a relation object, which is a lazily evaluated representation of the query. So it hasn't actually been run yet. It's run only when it needs to, such as when we display the results. And what you'll notice is that we've got a preview, and it's only given us up to 10,000 of that 100,000 sample that we've taken. So what that means is that if you have a really large data set and you're crunching some operation, you don't have to wait for the whole thing to evaluate to see how it went. If there was a much larger data set that's going to take a while, let's just have a peek. Did I get that transformation right? Cool, okay. Now let's actually go on until we run some command that actually requires us to materialize the full data set, whether it's saving it to a data frame or dumping it out into a Parquet file. The other cool thing that we can do is replacement scans. So you'll notice here that we have, we're querying from this relation identifier, and interestingly, that is not in the database catalog. It's actually the same identifier that we have in our Python process. So it goes, it's not in the catalog. I'll look back to see if there's any identifiers in the process, and there is a relation, so I'm going to query from that. The cool thing is that that query is streamed lazily through those relations. So this is actually a way of composing queries, kind of like you might with functions, in a really nice sort of way that works within how we're sort of arranging our queries in our Python notebook or what have you. So thinking about the tooling that you might use as a data scientist, really neat integration with a bunch of data tooling. DuckDB both can read and write to these in-memory data formats, and all of them can do that replacement scanning thing that I mentioned. So select from some identifier, and it's a pandas data frame. So you can query your pandas data frame, your polars data frame, which gives us really nice interactive loops between the tools that we already use. And if you're using Arrow, and sometimes I think pandas, you might actually, well, yes, with Arrow, and sometimes with pandas, you can get 0 copy, so it won't actually have to copy between data structures. There's also some really nice alternative query interfaces. So if you use dplyr in R, you can actually use the same query interface that you use to target DuckDB under the hood. IBIS is the equivalent of that in Python. If you were at Chip's talk earlier today, she was talking about that. So DuckDB is the default query engine for running IBIS queries, but you then get that portability of going across to different engines under the hood. And DuckDB also has a Spark, PySpark interface, so you can also run your PySpark queries on DuckDB libraries. I think I'm running out of time to get through all of the things. One thing I wanted to quickly mention about the different data types. So DuckDB has all these different database types, functions, and operators that help you with these kinds of data sets. One that I just wanted to point out is time series data. In addition to having some good timestamp and date and time types, we have the as of join, and that solves the problem of, if you want to join these two data sets that have different properties for events, they don't line up nicely. So you can't just join on the values. As of says, I want to join as of the next item ahead. So that's the query here. And if you didn't have an as of join in the syntax for your query language, which DuckDB does, this would be a much more gnarlier SQL query, and also probably slower, because this has been optimized. So that's just a nice little feature if you're doing time series stuff. Data management, all of the sorts of things. I'm just quickly mentioning that we get ACID transactions. You will roll back if you have if there's an issue with the query and not having to worry about data corruption. There is concurrency control. You can actually query 2 databases in read-only mode. And I think the other thing I'm just going to mention is the data catalog. So we've all had that experience of having far too many new CSV version 1, renamed Parquet.23, whatever it is, having a catalog to help sort of store all this actually gives you some controls to sort of tame that mess. And this is a cool SQL IDE called Harlequin that works in the terminal. And it's just showing you some of the different tables in the catalog, including, I've created some views, which you can put in there as well. So there's sorts of things that you're not going to get from a tool like Pandas or Polars, because they're just processing tools, not database management tools. And I think I'll just quickly mention, if you want to create a Streamlit or Plotly app, putting DuckDB as the data query engine in that is a great solution, because it runs in process. You can just import it into the process running that app, and then you can, the low latency properties that we get back from DuckDB make it a really performant option for creating those data apps. So I'm going to hand back to Simon to wrap this up for us.
Awesome. Thanks, Ned. So I know that we're standing between you and more afternoon tea, so I'll make the conclusion really quick. DuckDB, it's a tool that both a data engineer and a data scientist love. I love it for building blocks for the infrastructure and data products. Ned presumably loves this for all of that cool data science stuff. And I think what we really want to emphasize is it's an answer to all of these styles of workloads. Everything from data analysis, pipelines, data cubes, data apps. DuckDB is a fantastic answer to all of these styles of workloads. And with that, I wanted to say thank you very much for your time. And if you're interested, we wrote a book.
And there's also a bunch of stickers out on the table out there, so grab some stickers for DuckDB. And please.